Hello everyone, I hope you're doing well. In this tutorial, I'm going to walk you step by step on how you can test the regression hypothesis using JASP, which is an open and free software. So we have this conceptual framework with the arrows indicating the direction of the influence of X variables on Y variables. And we have some mediation variables as well. So first we need to start with the simple linear regression, like here in this variable performance expectancy affects positively intention to use AI for learning. So here we have the word effects. So whenever you have influences, effects, or has an impact or an effect on, that is regression. So regression tests the effect or the impact of one variable called the predictor or X variable on the other variable called the outcome or the Y variable or the dependent variable. So this is like this is the terminology. So here we have data already computed using JASP. I have been doing this in the previous videos, so you can watch the previous videos to understand what has been done. So we have the composite scores here of the Likert scale statements, and we need to run simple linear regression. So to do that, we have different windows here, and we could simply navigate through regression, and then we have correlation, linear regression. So this is in the same family of correlation, linear regression, logistic regression, generalized linear model, and Bayesian, which is correlation, linear regression, logistic regression. So I will just choose linear regression, and I will put PE, which is this one, and I will put it as the covariate, which is the name of the independent variable or the predictor variable or the X variable, on the other variable that I have on the framework, which is intention. So let me go back to intention, and I will put the dependent variable here, and I will get these tables. So I get the R, which is the correlation, the R squared, the like the variance that is explained by the IV in the DV, which is 54%. So this is correlation, which is 73. And this is the RMC, the adjusted R square, etc. So the ANOVA here in regression has special meaning. It tells you to what extent the model fits the data. So here we have the p-value. The p-value should be statistically significant. There is a way which we can just take this p-value and we just put the plain language term for it in the settings. And then the most important table is this one. So you could see here the p-value has a statistically significant positive influence of 797 on the intention to use AI. So that is the answer to our hypothesis. This is supporting the hypothesis. So if we just navigate to the model here, you could see the model terms, include intercepts, the statistics. We can just include the R-squared change, descriptive stats if we want to add descriptive stats, part and partial correlations, collinearity diagnostics, which are assumptions of regression. We could just also test the normality, the Durbin Watson test, the case-wise diagnostics for outliers, statistics. So within the same analysis, we can also test the assumptions of the test. Then method specification, and then we have plots. We can also include the residuals, the covariates, the residuals and predicted, the QQ plot, standardized residuals, partial plots, confidence intervals, prediction intervals. So marginal effects plot. So you see that it is highly customizable, and this the collinearity diagnostics, it should not exceed 0.5. So for collinearity, we have these are like some thresholds that I can share with you as well. The case-wise diagnostics for outliers as well. The residual statistics. So these are all statistics and visualizations that are needed in the regression, but I just showed you the most important table that answers the hypothesis. Also, you need to pay attention whether the regression is one-tailed, like whether the statistical significance test is one-tailed, like in our case, because we have the direction of the hypothesis, it has an influence that is positive, or two-tailed, which does not specify the direction of the influence. So this is in brief how we can run and interpret regression tests for hypothesis testing and what we can use to test the hypothesis. At the end, we can have a table like this in the result chapter, and then we can simply so we can put the result section, and we can divide it by each hypothesis. You can see here the same for the discussion. And here you have a table like this where we specify the directions of like here PE for hypothesis 1, influencing, let's say, intention. And this is the beta coefficient, I put it here, and the p-value, I put it here, and the decision here is supported, meaning that PE has statistically significant positive influence on intention. I could add symbols here to put like, so this is in brief how we can do it and how we can even interpret the results. Yeah, so you can find some appropriate symbols here, like this one, like this. This shows the direction of the influence, meaning PE influences intention. That's it. So, and then I will continue like this for the other tests. Let's say performance expectancy affects positively AI literacy. I will do the same, and I will need to complete this table. Let's say AI literacy, so EL, and then I will need to put the beta coefficient and the p-value. So go back here, and then I would change intention into AI literacy. And once we go to the data analysis output, here we have again an influence of 684. So I will just type it 684, and it is statistically significant. Then we do the same for AI literacy affects intention. So I will simply copy this. AI literacy. So here you see that I keep running single or simple linear regression multiple times and just getting the beta coefficient. So again, going back to JASP, and then I will change, I will just reverse this. So AI literacy affecting the intention. So I will put it like this. And here is the influence 886. So I will put it like this. And the fourth one, AI literacy mediates. So here the mediation variable is going to be treated differently. So performance expectancy affects positively AI accessibility, or just this one, AI literacy mediates the relationship between performance expectancy and intention to use AI for learning. So this has like special tests that we can run, and so I will show you this later in another video, how to run mediation, moderation, control variables with regard to regression analysis. For multiple linear regression, suppose you want to test all the variables at once, you can simply put here the intention and you just populate all the other variables here, like performance expectancy, like this one. So here you go. So this is called multiple linear regression. So you will have one table with all the influences. So this is like how we can interpret that. And you see when they are combined together, the unstandardized beta and standardized beta tend to decrease. You see, when you have a direct influence, it's not like when you have an influence with the combination of all the predictors at once. You can compare which one has the highest influence, which is this one, EL, followed by PE, followed by AI. So this is how we can run multiple linear regression at the same time. If you have some questions or remarks, do not hesitate to post them below. See you soon. Bye for now.